Hello students, welcome back to online classes. In last video we discussed about the polymers. So means what are polymers and the classification of polymers. On the basis of 5 classification we are going to divide the different kinds of polymers. Okay, in today's class we will discuss about the types of polymerization reaction. Okay, the types of polymerization reaction. Here we will come across two types. One is the addition polymerization reaction or else a chain growth reaction. So addition polymerization, it is also called as a chain growth polymerization process, and another type is the condensation polymerization reaction or the step growth polymerization. Okay, in that first one is the addition polymerization reaction. So already we know that the addition polymerization means here the monomer, the repeated structural unit must be contain double bond or else a triple bond. The monomer must contain double bond or else a triple bond. It may be same or else a different. So two different monomer are able to combine, and also the same monomer also combine to give the polymer reaction. But in this addition reaction we will not get any eliminated small products like water, HCl, etc. So here there will be no chance of elimination of a small molecule. So that polymerization reaction is considered to be the addition polymerization reaction. So in case of addition polymerization process, the chain growth will be taken place. So as a result it is also called as the chain growth polymerization reaction. So the types of polymerization reaction consists two types. One is addition polymerization and another one is the condensation polymerization. So firstly we should discuss about the addition polymerization process. Addition polymerization, or it is also called as the chain growth polymerization . So it is called as chain growth because during this process the length of chain should be increases. So that is nothing but the chain growth polymerization process. So addition polymerization means the monomer or also repeated structural unit, it must be unsaturated one. So usually alkenes and alkadienes will undergo this type of a polymerization process, and however it can be done with two types. One is either by free radical mechanism or else sometimes it is also produces the ionic species. So through free radical mechanism also we can able to carry the addition polymerization reaction. So firstly we have to know what is the definition of the addition polymerization process. We can simply write the addition polymerization is nothing but the molecules of same or different monomer. This monomer must be unsaturated, means it must contain the double bond or else a triple bond. So those monomers can undergo the addition polymerization reaction. So same or different monomers are added together on a large scale. So they will use the polymer molecule to form a polymer. Okay, so this can be taken place by the formation of free radicals or through the formation of ionic species. So the free radicals are nothing but the species which will carry odd number of electrons. So that is called as the free radical. Ionic species is nothing but they must contain either positive charge or else a negative charge. So in this way we can do the addition polymerization, and during this the chain growth will be taken place. So that is why this type of polymerization is also called as the chain growth polymerization process. So firstly we can discuss through the free radical mechanism, the addition polymerization through the free radical mechanism. The process of formation of polymer is called as a polymerization. Okay, so here in this free radical mechanism, so whenever we are studying the polymerization reaction, we have to remember three steps. One is the chain initiation. Firstly, the initiation of chain should be started, so that is called as the chain initiation process. And secondly, we have to know the chain propagation. So propagation of chain should be taken place in this step. And thirdly, the chain termination. Okay. So each polymerization reaction, it should be carry over through these three steps. Firstly, the chain initiation and chain propagation, and lastly the chain termination should be taken place. Here also in the free radical mechanism we have to follow all the three steps. So in the first step means the chain initiation, so it should be taken place by the use of some of the catalyst or else starter materials. So those starting materials are also initiators. Here it is called as a catalyst. So we are using a small amount of catalyst to initiate the polymerization chain. So that is called as the polymerization chain initiation step or also chain growth step. Here we are using the peroxide molecules as a catalyst. So we are using the peroxide groups as a catalysts. So the peroxides are nothing but they must contain oxygen to oxygen linkage. So this kind of molecules are said to be the peroxide. So there is a presence of this group in any molecule, then it is said to be peroxide. For example, the benzyl peroxide or also acetyl peroxide, so etc. So in this way, here we are going to use any peroxide catalyst to initiate the chain of polymerization. So first, if we are using the benzyl peroxide as a catalyst here, so benzyl peroxide, so already I said it must contain O linkage. So this is the benzyl peroxide. Okay, so we are using the benzyl peroxide or also acetyl peroxide or also tertiary butyl peroxide as a catalyst or as a initiator. If I take the benzyl peroxide, so C6H5 C double bond O linkage to that of C double bond O C6H1. So this is the benzyl peroxide initiator or also catalyst. So this should undergo homolytic cleavage. So homolytic cleavage, as a result of homolytic cleavage, the equal number of electrons, they will move towards the neighboring atoms. So here there is a presence of one electron and here there is a presence of one electron, means each bond is formed due to the sharing of two electrons. So one electron will goes to this and one electron will goes to this, since it is called as homolytic cleavage. As a result of rupturing or else a cleavage of this bond, the creation of radicals will be taken place. Now we can write 2C6H5 C double bond O, and O should carries one electron. So that is called as the free radical. So due to the rupturing of this bond, we will get the formation of two free radicals, and this will undergo again the cleavage will be taken place. So this will undergo the bond which is present in between the phenol and this carbonyl carbon. Again they should undergo cleavage. As a result of this, the moving of electrons will be taken place, since we will get the formation of a 2,6H5 radical, means the phenyl radical. 2,6H5, here carbon will carry one odd electron, since it is called as the phenyl radical. Further, this will carry C double bond O, and this oxygen will carrying one odd electron, and this carbon will carrying one odd electrons. They should make bond with each other and they will eliminate as a CO2 molecule. Okay, so whenever two radicals are near, they should make the bond and they should eliminate it as a CO2 group, and here we will get the phenyl radical. So this phenyl radical will initiate the chain polymerization process. So this is required for the initiation of a polyethylene process. So if I take the second step, so this is the chain initiation. So during this chain initiation, initially there is a formation of free radical will be taken place. So now formed phenyl radical, it should react with the ethane moiety. So if I take the example of formation of polyethylene, so then this phenyl radical will interact with the double bond which is present in the ethane molecule, that leads to the formation of the first product. So for example, CS2 double bond CS2 plus this phenyl radical C6H5 radical. So here also there is a presence of electrons. This should undergo homolytic cleavage. As a result of this, we will get the formation of a radical of two ethene groups. So but one of the phenyl radicals, see here I will show CS2 radical, and this radical is interacted with the phenyl radical. As a result of this, they will make the bond. So since this reaction, there is a formation of bond will be taken place in between this phenyl and this ethyl group, and there will be a presence of one more odd electron over this ethene. So this will further react with the another mole of ethane moiety. So since now we can write it as C6H5, bond will be taken place in between CS2 and this C6H5, and there is a creation of one more radical here. So this is the first step which is occurred in the polymerization process. So this step is considered to be the chain initiation reaction. So here chain initiation will be taken place through the formation of a free radicals. So this free radical is further reacted with the ethene molecule. So then it will create a one more radical. So this radical is further reacted with the upcoming or else many number of ethene molecules. So in case of chain initiation, you have to remember the catalyst will be initiated the process by reacting with the reactant molecules. Here I am taking the polyethylene as a example, so that is why I am going to react this phenyl radical with the ethene molecule. So this is the first step. So in next step we have to see the chain propagation. Okay. So this is the radical which is formed during the chain initiation step. So this is the product. So the first step product. So further in case of chain propagation, so this is first steps. In second step we should learn about the chain propagation. So as the name suggests, so propagation is nothing but growthing or else a continuous lengthening. So chain propagation will be taken place by the addition of this radical to the upcoming ethane molecules. So n number of ethane molecules will add it to each other and they will propagate the chain, means they should lengthening the chain. So that is called as a propagation. Okay, here so this C6H5 radical is reacts with the one more ethane molecule here. Okay, so this ethene molecule is also undergo cleavage. As a result of this, so this double bond is undergo cleavage and there is a formation of radicals will be taken place over both the carbon atom. So this radical is reacts with this radical moiety, means both are involved in the formation of a bond. So as a result, I will write bond here and this will be remained as a same. So that's why now bond is formed, a new bond is formed in between this CS2 molecule to the new ethene molecule. As a result, the length of chain should be increases. See here. So firstly we will have only this much of length. Okay, only this much. But whenever it should added to this ethene molecule, then we will get the formation of this product. Okay, now we can write it as plus CS2 CS2, we will get this product. Okay, so if I add one more ethene molecule, again the chain should be increases. Okay, again the bond will be formed in between this CS2 to this CS2, and there is a creation of radical will be taken place over this ethene moiety. As a result, it is further pickups one more ethene molecule. In this way, the chain should be propagated, or else the chain should be increased, or else lengthened. So this step will be called as the chain propagation step. And in this way, n number of ethene molecules will goes on added to this chain, and we will get the formation of a polyethylene. And the next step is how this chain should undergo termination. Means we are going to get the final product in the chain termination product. So in this chain termination, as the name suggests, termination means at the end of chain, or else the end of the reaction. So here the two such molecules, means two this kind of molecules will interact with each other, and they should give the formation of the polyethylene molecule here. So that is called as the chain terminating, or else chain terminating step. Here we are going to terminate this chain. So here in this step, the two such kind of molecules will interact with each other, and finally they will give the formation of a polyethylene molecule. I will write here C6H5 CS2 CS2 CS2. I will stop here only because the chain should be lengthened. So I will stop here only. It should react with the similar chain C6H5 CS2 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 here. So in this chain termination, so this radical is reacted with this radical moiety. As a result, a new bond is created in between these two carbon atom. Now there is no free radicals more. So there are no free radicals here after the formation of the bond in between these two carbon atoms. So as a result of no free radicals, so further the addition of ethene should be avoided. As a result, the termination of chain should be occurs here. So see here. Now we can write it as C6H5 CS2 CS2. So now we can write N here only, because the addition of N number of ethene molecules should be taken place in the formation of polymerization reaction. So that's why CS2 CS2 N, then CS2 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 C6H5. So in this way the propagation and termination will be taken place. So every polymerization reaction should occur through these three steps. One is the chain initiation, and secondly the chain propagation, and thirdly the chain termination. In the initiation, the free radicals will be generated. So those free radicals will interact with the 1 mole of ethene moiety. Then in case of chain propagation, n number of ethene molecules are added to the first step product. As a result, the length of chain should be increases, and it is propagated with the addition of many number of such a molecules. Then in the last step, the termination of a chain should be taken place by the reaction of two such a molecules through the formation of a bond in between the carbon molecules. So this is about the polymerization process, and it is occurs through the free radical mechanism. So in this way we will get the formation of a polyethylene. And moreover, this chain initiation, so whenever addition is taken place, so I write it as the phenyl radical is reacting with the CH2CH2. So this radical is interact this ethene molecule with the presence of small heat or else sunlight. Okay, so it should be remembered. The chain initiation will be taken place in presence of sunlight or else a small amount of heat. Then we will get the formation of this product. Further, it should interact with the n number of molecules. So this is about the addition polymerization through free radical mechanism. So next we will discuss about the preparation of some important addition polymers. So here we will come across again the polyethylenes and Teflon materials, means Teflon polymer. So firstly we should discuss about polyethylene, preparation of some important addition polymers. Remember this one, all these polymers are addition, so there is no elimination of small molecules will be taken place. So in that first one is polyethylene. So we have two types of polyethylene here. So one is the low density polyethylene and another one is the high density polyethylene. So through this addition polymerization we will get the formation of low density polyethylene. Low density polyethylene. So it is called as LDP, low density polyethylene, and another one is high density polyethylene. So it is called as HDP. Okay, polyethylene is nothing but this one, CS2, CS2, CS2N. So we can prepare through the two kinds, one is low and another one is the high density. So in this step, means in case of low density polyethylene, we will get the formation of polyethylene molecule at a high atmospheric pressure as well as high temperature with the presence of small, very small amount of catalyst, means minute amount of catalyst is required here. So that is called as the low density polyethylene molecule. So it should get, means the polymerization will be taken place under high pressure and high temperature. So here we are required the atmospheric pressure of about 1000 to 2000, and here temperature is also high, about 350 Kelvin to 570 Kelvin. Okay, so this polymerization process will require high temperature and high pressure. Here only minute quantity of catalyst is used. So usually the dioxygen or else the peroxide molecule also used here. So peroxide or else dioxygen, here also they will be acting as a catalyst only or else a initiator. So this is also obtained through the free radical mechanism. So the low density polymerization reaction is occurs through the free radical mechanism, and here we will get some kind of branching due to abstraction of a hydrogen atom. So here we will get the branching of chains will occurs in case of a low density polyethylene molecule, and moreover These low density polyethylene molecules are chemically inert one. So chemically inert means they will not react with any chemicals. So this is called as the chemical inert. So whenever we are preparing these polyethylenes by providing high temperature and high pressure, so those will become the chemically inert, and but those are flexible in nature. Flexible means we can mold it in any shapes. So usually these are useful in the preparation of wires. So we are useful for the preparation of wires. So the second property of this will be these are chemically inert and also tough, means this will hard. The main important property is flexible. Since we are using in the electrical insulating materials, because this will not able to conduct electricity properly, so we can say it as a poor electrical conductor. So because of this reason we can use, means it is not able to conduct electricity properly, since we can use in the preparation of electrical insulating materials, and due to its flexibility we are going to use this polyethylene in the preparation of wires. Okay, so these are the properties of low density polyethylene. So this low density polyethylene should undergo free radical mechanism polymerization, and it should be required of about 1000 to 2000 atmospheric pressure, 350 to 570 kelvins of temperature, and very small amount of catalyst is needed. So usually we are using peroxide or else benzyl reaction initiator, and nextly it should undergo hydrogen abstraction. As a result of this, the branching of chain should be occurs. Next, it is chemically inert in nature, means it does not react with any chemicals, and it is tough and it is flexible in nature, and it is poor in the conducting of electricity. So if we see the uses of this low density polyethylene, it is used in the preparation of wires and squeezing bottles as well as the insulating materials. So this is about the low density polyethylene. So if you move towards the high density polyethylene, so here it is formed whenever addition of polymerization of ethene takes place in a hydrocarbon solvent in presence of a catalyst here. So here we are requiring high temperature and high pressure for the preparation of low density, but in case of high density polyethylene we require only minimum amount of temperature and minimum pressure as well as temperature, because here we are going to use the one of the catalyst, so that is called as the Ziegler-Natta catalyst. So Ziegler-Natta catalyst. So this catalyst is helpful for the preparation of the long chain high density polyethylene. So Ziegler-Natta catalyst is nothing but the tri-ethyl aluminum. When it is combined with the titanium tetrachloride, it will give the Ziegler-Natta catalyst. So by using this Ziegler-Natta catalyst, we will able to produce a high density polyethylene. Here the temperature required for this reaction it should be 333 to 373 Kelvin, and here the atmospheric pressure only we required about 6 to 7 atmospheric pressure. But see here, in case of low density we required about 1000 to 2000 atmospheric pressure, but here we will get only 6 to 7 atmospheric pressure, and moreover we will get the linear polyethylene molecule here. Okay, in case of high density, so we will get the linear polyethylene molecule. It is due to the close packing of ethene molecules. So each ethene molecules are arranged in a closed manner. As a result, we will get the formation of a linear polyethylene, and here it is also the chemically inert in nature. So this high density polyethylene, it is also chemically inert one, but it is rigid in nature. It is rigid, so we can't flex this polyethylene molecule, so that is why it is called as a rigid one. But low density polyethylene is flexible in nature and it is more tough compared to that of low density, so it will become more hard and more tough compared to low density polyethylene, since it will not able to mold in any wire shaped materials. So that's why it is used in the manufacturing of the very tightened plastic materials like dustbins, buckets, etc. So these are the uses of high density molecules. So buckets, dustbins, bottles, etc. Because of its rigidity and more toughness, we are going to use in the preparation of more hard materials, but due to its flexibility, we are going to prepare them in the manufacture of electrical conductors, electrical insulating materials and wire materials. So this is about the polyethylene molecule. So in case of polyethylene, we should have two types, one is low density and another one is the high density. So in case of low density, it require high temperature and high pressure, and in case of high density polyethylene, it should require the Ziegler-Natta catalyst. You have to remember the composition of this catalyst. Okay, so triethyl aluminum plus titanium tetrachloride togetherly called as a Ziegler-Natta catalyst, and it is soluble in the organic solvents. Okay, this is about the polyethylene. So next is the Teflon, the preparation of Teflon or else polytetrafluoroethane. Second one is Teflon material. So it is called as polytetrafluoroethane. Simply it is commonly called as Teflon. Okay, as the name suggests, here the starting materials or else the monomer is CF2. So whenever n number of these tetrafluoroethane molecules are added to each other, they will make the formation of a polymer of this. So here also we require a catalyst. So in presence of catalyst, this should undergo polymerization. For the process of polymerization, we should require n number of tetrafluoroethane molecules. They should undergo polymerization. As a result of this, and here it is required high pressure. In presence of high pressure, they should form the polytetrafluoroethane chain CF2N. So instead of CES2, you have to write CF2. So if you write instead of hydrogen fluorine, then it will become Teflon or else a tetrafluoroethane. So already we know this Teflon is usually used in the manufacture of cooking utensils because it will become more hard. As a result, we are able to prepare in the cookware utensils. So it is resistant to corrosion, and it is chemically inert in nature. So since it is used in the preparation of non-stick materials and gaskets, it is used in the preparation of gaskets and oil seals and non-stick surface coated materials. So this is about the Teflon. So n number of tetrafluoroethene molecules should undergo polymerization reaction in presence of catalyst, or else in presence of catalyst and high pressure we will get the formation of this poly tetrafluoroethene chain. So this is hard in nature and it is resistant to corrosion and chemically inert in nature, since it is used in the preparation of non-stick materials and gaskets and oil seals, etc. So this is about the Teflon. So the last addition polymer is polyacrylonitrile. Polyacrylonitrile. So you have to remember uses also. So many times they ask about uses or also applications. So with the properties you have to remember the uses of each polymer, then it will helpful for you. So the third one is the polyacrylonitrile. So this is also the addition polymer. So here acrylonitrile should undergo polymerization reaction in presence of, so this is acrylonitrile. In presence of peroxide catalyst, it should undergo polymerization. So here also n number of acrylonitrile molecules should react with each other, means they should added in a covalent bond, then we will get the formation of a long chain of a polyacrylonitrile complex. So here CS2 CH CN. So this is the repeating unit or else a monomer. So when n number of polyacrylonitrile molecules are added togetherly, it will give the formation of a polyacrylonitrile polymer. So this should undergo polymerization process in presence of a peroxide catalyst. During polymerization process we require usually catalyst only. So in presence of catalyst or initiator, the chain initiation step should be occurred. So that's why all the polymer process will require the catalyst. You have to remember which catalyst is useful for the each material. So usually we are going to use the peroxide catalyst. You have to remember the benzyl peroxide catalyst. Okay. So these are the four materials which we are able to get in the addition polymerization, three materials in the addition polymerization reaction. One is polyethylene, secondly Teflon means polytetrafluoroethene, and third one is the acrylonitrile. So this acrylonitrile is useful in the making of wool or also commercial fibers. Okay, this is useful in the preparation of wool making, of commercial fibers, and it is also used in the acrylene or also orolene. So this commercial fibril is called as the acrylene, also orolene. So this is about the acrylonitrile. So these are the important polymers of addition polymerization process. The first one is polyethylene, polytetrafluoroethene. It is also called as Teflon, and third one is polyacrylonitrile. You have to remember use of each polymer material. Okay, so this is about the addition polymerization process or else a chain growth polymerization process. So the next another type is the condensation polymerization or else a step growth polymerization. So it should be discussed in the next video. Okay, thank you.